We are not very, okay, Seth built something out of his imagination, a conveyor belt, transmission. Okay, so I did look at your pictures if you uploaded them into Moodle this morning. Those of you who did, thank you very much. I had also sent you guys an email, or your parents an email. We are looking for volunteers to allow me to use a picture of you and something that you built out of your Connects kit so that I can use it in a presentation we're making to kind of advertise our learning labs. So if you would be willing to do that, have your parents send me a picture of you with whatever you built, and excuse me, I will use it in our presentation. So here we are in week 5 of robotics, and what I would like to start with is I'd like to see what you built. Then we are going to talk about different parts of a robot, and what I want you to be doing as we are talking about the parts of a robot is I would like you to try to make a connection to the machine that you built. So you didn't build a robot that you programmed, but you all built parts of a robot or parts that can be used in a robot. So I am just going to go in order. If you would like to share, turn on your video screen, and then I will turn you on. You'll have to click OK under my picture. So Clinton, I'm going to start with you. Raise your hand, Clinton, if you're good with me turning on your camera. Okay, Clinton, I'm going to turn my video off and turn Clinton's camera on so we can check him out. Okay, why don't you turn your mic on too, Clinton, and then maybe you can tell us about what you built.
I built the paddle boat. There's different ways you can use it as a robot. There's a few ways I figured out you could use it is by transporting goods from one place to another and mixing something up. It was fun to build though.
Can you hold it up a little higher so we can see it in the camera? I can see you. Perfect. All right, great job. And there is Clinton's paddle boat. Awesome. Thank you for volunteering or being willing to go first. Okay, Dane, go ahead and raise your hand if I can turn your camera on, please. All right, and maybe Dane doesn't want his on today. Dylan, are you willing to share what you made on the camera? If so, go ahead and raise your hand, Dylan. All right, I'm going to turn your camera, and you can turn your microphone on. Make sure you click OK. There you go.
Okay. So what I built was a transmission, which was really fun to build. Lots of little parts and a little fan, and it has 3 different modes you can put it on. Currently, I have it in first gear, which is pretty neat. And so it can go into first gear, second gear, and neutral. And to change the gear, here is this. So you move this, and that is neutral. That is first gear. And then second gear, which is the fastest, there. And there is second gear. And you twist it. Oops. The gears moved a little bit. There we go. So then there's second gear. And neutral, I dropped it, darn. There we go. And the neutral is when you twist it, it just doesn't really move very quickly at all. And that is what I built.
All right, great job. Thank you very much for sharing, Dylan. Isabella, would you like to show your picture or your creation? If you do, go ahead and raise your hand. All right, let me turn your camera on, and you can turn your mic on. Okay, remember to turn your camera on. You have to click the little OK or allow that pops up under where my picture normally is on your screen. Over on the top left, Isabella, where my picture normally is, your screen may be black now, or you may see your picture. Go ahead and click OK, or allow, or start, whichever comes up. All right, well, we'll let Isabella fix hers. Joseph, would you like to share yours with us? Go ahead and raise your hand if you'd like to share yours, Joseph. All right, let me turn on your camera. It should be on. You need to click the OK button underneath where my picture normally shows up on your screen, and here you come. Hold on, Joseph. Your camera didn't come. Oh, there you go. All right, perfect. Go ahead. Very nice. Joseph built the hammer, which certainly can be used in robots or by robots. Great job. Thank you, Joseph. Kyle, we'll give Isabella a couple more minutes to fix hers. Kyle, raise your hand if you would like to share yours. All right. Go right ahead, Kyle.
Here's my carousel. It has two modes. It has slow and fast. And then the slow mode, I went with the second mode, the fast mode. And then it has the benches and the crosses. And then the faster you turn it, the more it goes. It looks better on a flat surface, but you couldn't see it as good on a flat surface. And then I added that just for a little design. And that was my carousel.
All right, fantastic. Thank you very much, Kyle. That is definitely one of my favorites. Good job. Okay, Isabella, we're going to go back to you. Go ahead and click the allow or OK button that comes up, and here you come.
Okay, so here's my command results. It took me 9 minutes to get them all back with just together. And this can be used in factories and stuff like that. So.
All right, great job. Thank you very much, Isabella. Now, as you guys are observing each other's. A lot of you are writing things in the text chat, which is fine. As long as you're commenting on the projects, I'm okay with that. But I want you just to kind of be thinking about how these things, these conveyor belts, these carousels, all could be used in robotics. All right, Lindsay, you are next. Raise your hand if you would like to share your creation. Fair enough, Lindsay. All right, Luke, would you like to share yours? Go ahead and raise your hand, Luke. All right, Luke, your camera is on. Go ahead and click the OK or the yes, and here you come.
I built the tow truck, and me and my brother made some changes. Instead of what it showed for the hook and the directions, I put this piece on. And we made sides here, like a door. And we made a steering wheel and a front.
All right, great job, Luke. I really like the adaptations that you made to that. I'm guessing that you have lots of Connects at home that you work with. So, awesome job. And let's go ahead and Millie, you are next. Would you like to share yours? If so, raise your hand. All right. Noah, yours says you have no camera enabled. Seth, would you like to go ahead and try yours, or can you not show yours? If you want me to turn your camera on, go ahead and raise your hand. All right, then Stephen, go ahead and raise your hand if you would like me to click your camera on. No. Okay, fantastic. What we are going to do now is we are going to switch over to our whiteboards. I'm unlocking everybody. So you all should be able to write on your whiteboard. And what I want you to do is you made a creation. Whether you made it from the Connects kit or someone said that they made their own creation, or Luke went ahead and modified his creation. So you made a creation. The chat room is probably blinking, Kyle, when somebody writes something. I believe when someone writes something, so like if I write hello, it is going to cause the button to blink until you click on it. Okay, Seth, if you want, you can go ahead and take a picture of it and send it to me, and then I can email it to me. And then I can put it up in the beginning of the class next week, and you can share your creation. So you guys each made some sort of creation. I would like you to think about this question and write your response up on the whiteboard. So you made a creation. If we added a programmable computer to your creation, What could your creation accomplish? And I'm going to, before you write anything, I'm going to explain to you what I mean. This is what I mean. So there's my question. And we are going to pretend that I built the fan, like we did in class the other day. So if I added a programmable computer to my creation, which is the fan, what could it accomplish? Well, with a programmable computer, my fan could cool a room to a certain temperature. It might be able to propel a vehicle through the air. It might be able to move something through water. I want you to come up with, let's say, 3 things your creation could accomplish. So go ahead, find a spot on the whiteboard, and tell me 3 things your creation could accomplish if you added a programmable computer to it. Okay, and it would be great if you could also tell me what your creation was. So like whoever's writing on the bottom left here is writing a paddle boat could. Tell me what you made. Okay, Millie just wrote that she can't see what people are writing. What I want you guys to do if you're having that problem is look at the bottom left-hand side of your whiteboard. It should say page 1 of 1. Then next to that, there should be a drop-down box that says group. I'm not sure why it is saying locked. I have your erasers locked so no one can erase what we have up there. Okay, make sure you're only writing on your spot of the whiteboard. Don't delete someone else's text, please. I'm going to give you guys 3 more minutes. All right, finish what you are writing. And then we are going to take a look. Okay, I'm locking everyone so no one can write anymore. If you weren't done, we'll try to figure it out. Okay, so here's what you guys wrote. First, we are going to go ahead and take a look over here on the left-hand side. It could move by itself. It could move faster or slower without changing the way you crank it. It could move the animals and seats up and down. It is a carousel. Great job. Over here in red, we have cracking nuts, saving your teeth from being chipped, cracking nuts at a faster speed than your hand. If I made a hammer, it could fix with no one there to do things. Very good. We have Dylan's. I made the transmission. It uses voice commands to start your car. It could have a self-driving car. Sensors could tell the driver if something was wrong with the transmission. Okay, it looks like some got deleted. Hopefully as we're going through here, they show up. And that one. We have a paddle boat. Could show tourists around on its own without a captain. It could go back and forth to bring people or things to a place. It could be a fast and fun ride like something you would see in Disney World. If you move to the right, you will see it says it could feed the paralyzed in the arms and test how long something could stay on. And on the bottom we have a conveyor belt. Could move people up inclined areas, be used in factories to move parts through an assembling line, and move vehicles on soft terrain. All right, if yours got deleted, I'm not sure why. We will try and work on it for next week. But right now, we are going to go ahead and we are going to take a look at the parts that make up a robot. So if you look at your PowerPoint screen, we have parts of a robot. There are 4 main parts that make up the most simple to the most complex robots. We have sensors, controllers, actuators, and mechanisms. There are two types of sensors, physical or logical. Anyone want to guess the difference between physical and logical sensors? Raise your hand. Isabella, go ahead.
Logical sensor has like a chip telling it like how to rationalize.
All right, Clinton, let's hear your guess. I wasn't able to hear your microphone, Clinton. Go ahead and try that again.
A physical sensors is sensors that you know when to do something, or you get poked by a needle, you know you got poked. But logical sensors are ones that you think of and not, you can't really feel it at all.
All right, Kyle, did you want to add anything to either of those definitions, or do you have one of your own?
The physical is like if a robot was driving and he almost runs into the wall, he would turn or go away from it. And a logical would probably be like when I don't know, I only had one for the physical. I don't really know what the logical is.
Okay, fair enough. Well, let's take a look at physical and logical sensors. A physical sensor handles the raw processing of data. So a physical sensor is, I hit a wall. That's it. Or there's a wall that comes across the laser beam that is going out of the robot. A logical sensor then extracts the data for interpretation. So the physical sensor may say, there's a wall 10 feet ahead of us. The logical sensor is going to kind of make a decision. Okay, there's a wall 10 feet ahead of us. What do we do now? There are three types of sensors. Take a look at these for a second and think about the words inside of here to see if you can figure out what any of these mean. These are three different types of sensors that hopefully we are going to have time to get into. But instead of getting into them first we're going to talk about the actual robotic components and different types of components. So the next part of a robot is the controller. Does anyone want to read this slide for me? Any volunteers? Kyle, go right ahead, Kyle.
Controllers. Controllers. Interface between the robot and environment. It provides intelligence and feedback to the robot. It also stores the sensory information and inputted programs. It includes the hardware that interacts with the outside world.
All right, very good. Basically, this is the computer component of your robot. The next part of a robot is the actuator. Now, the actuators are a mechanism for activating a process control equipment using either pneumatic, hydraulic, or electronic signals. And there's two types. There's a synchronous actuator and an asynchronous actuator. Now, we sort of talked about actuators, although we don't use this term, when we talked about how parts of a robot are similar to parts of a human. We had talked about the wires and how, like, our body has nerves where nerve impulses are sent down them, how the wires are what sends signals between different parts of the robots. This is what the actuators do. Now, a synchronous actuator is a motor that contains a rotor that rotates in synchrony with the current. And here's a picture of a synchronous actuator. Synchronous actuators are pretty common in robots. There's three types: a brushless DC servo. Now, obviously, I don't expect you to remember these names, but I want to expose you to some of this vocabulary. So a brushless DC servo is an electric motor that uses permanent magnet poles on the rotor. Now, when you have two magnets, they are either blank or blank to each other. Anyone know what those blanks would be? If you have two magnets, they are either blank or blank to each other. Kyle.
That attract to each other, they either attract to each other or repel each other.
Awesome job. They are either attracted to each other or repel each other. So in a brushless DC servo actuator, the rotating poles have magnets with opposite polarity, so it allows and causes the rotor to spin. Advantages of a motor like this is that they are very quiet. They last a long time because the magnets don't wear out. They are very efficient. They do not use a lot of energy. The next type of motor is called a stepper. A stepper is another small electric motor. It usually rotates in small, discrete steps. So you can kind of think of it like a gear, slowly slipping past each other. It goes like in little hops or little steps. The drawback of the stepper motors or the stepper actuators is that they use lots and lots of energy. And the last type of synchronous actuator is a brushed DC servo. A brushed DC servo is a coil that is wound around a rotor, and then it's powered by a battery. Depending on how much voltage is delivered depends how quickly the motor moves. The advantage of a brushed motor is cost. It is much cheaper to run this kind of motor than a brushless servo. The other type of actuator is an asynchronous actuator. Now, an asynchronous actuator is a type of electric motor that's designed to slip a little in order to generate the torque. So here's a picture. And there are 4 types of these motors. The first one being a traction motor. Traction motors are used to power the wheels of your car. They are very reliable and very practical. The AC servo motor is very quick and accurate. They're tiny, and they are used for things that need a fast stop and a fast start. A pneumatic motor is powered by compressed air. They're not very strong, so they are used in applications where they don't need a large amount of force. And the last is a hydraulic actuator. A hydraulic actuator changes hydraulic pressure into torque. Hydraulic actuators are used when a large amount of force is needed, like a piston. We are going to go ahead and take a look at some, I think there's 10 in the video, 10 common robots used in factories. While we are looking at this video, I would like you to pay attention to how these different robots move. So you might want to take a piece of paper if you have one and jot a few down. You are not going to catch all 10 of them. I want you to actually watch the video. But if you could pick one of the robots on the video, and write down on your paper how it moves. Does it move straight and back and only make one motion? Is it a complex motor that picks things up, puts things down, and then puts them somewhere else? Pick one and pay attention to how it moves. So in order to watch a video clip, we are going to make it so you can see all 4 rectangles. You're going to look at your bottom right rectangle, which is our whiteboard. Make your whiteboard screen larger. There should be a couple of icons at the top toolbar. You're going to click the last one that says Applications. You should now see the word Robot. Do not click on anything yet, please. Go ahead and answer yes or no. Can you see the word robot? Okay. For those of you that can't, you are looking at your 4 rectangles. You are going to look at your whiteboard. On the top of your whiteboard, okay, I'm not sure what's wrong with your whiteboard, Millie. What I would like you guys to do is click the word robot, and you can watch the video. Millie, I'm going to put the link in the text chat so that you can click on the video as well. Okay, we have a couple of more people that we are waiting for to get back. When you are back, please go ahead and click on the yes button. Okay, I'm waiting for 2 more. Luke and Noah, if you are done, please click the yes. Okay, so thinking about those robots that we just saw, which one do you think was the most complex and why? Which had the most complex either movements or job? Raise your hand. Which do you think had the most complex? Clinton, go ahead.
I think the one that had the most complex in movement was the one that was welding, because it had to get just perfect and can't move a little bit unless it's welding a straight line. It has to be perfect measurement from away and to it. So.
Perfect. Okay, Kyle and then Isabella. Kyle, go ahead.
Try the one with detail that cuts it out and welds things and welds small things on and does the details.
All right, great job. Isabella, which one, in your opinion, is the most complex?
The assembling one would probably have the hardest job because it has to move extremely quickly while the things are coming on. That one and the assembly one, because like the welding, it has to be very, very precise with its movements because if it gets off, it could break.
All right, great job. Now, thinking about those 10 robots we just watched, we are going to go ahead and look at the ways robots move. And this is called the manipulator. There's arms and bodies, which are used to move and position parts or tools within a workspace. This is up on the PowerPoint screen if you're looking for it. Usually, the arm and body are 3 joints connected by large links. Now, when we talk about these manipulators, we are talking about what I would call old robots. Robots used in industry, robots that are doing a certain task. I'm not talking about a robot that's diving down into the ocean to find something. We're talking about robots that have an industrial purpose. So they have an arm and a body, and they also have a wrist. The wrist is used to orient the parts or tools at the work location. And this is usually 2 or 3 smaller joints. There's 5 types of mechanisms. We saw examples of all 5 of these in the video we just watched. The first are Cartesian robots. Cartesian robots have 3 dimensions of movement. They can move forward and back, right and left, up and down. They work great in spaces like a rectangular box. They are great for precision, repeating tasks, and they're used in material handling. So here is kind of 3 pictures of how these robots work. The first is the principal. That's where you can move up, down, right, left. The structure of it is in the middle, a sample one. Obviously, there are more complex Cartesian robots, but this would be a simple one. And then the workspace. The workspace of a Cartesian robot is a rectangular box. The next mechanism is a cylindrical robot. A cylindrical robot is a robotic arm that moves around a cylinder-shaped pole, like you see here in the picture. It is used for product assembly and spot welding. And here are the pictures that go with it. The diagrams are the first 2, and then the last one shows you where a cylindrical robot works. Here we have a spherical robot. A spherical robot has 2 rotary joints and 1 linear joint. They're used for welding, painting, and assembly. The first robot for industrial use in the 1960s was a spherical robot. This is to show you how a spherical robot looks. The first robot used in industry was in the 1960s, and it was made by Joseph Engelberger, based on a design by George Devall. George Devall created a basic design in 1954, and Joseph Engelberg advanced that design in the mid-60s. The first robot was installed at a GM manufacturing plant in New Jersey. The robot had 2 jobs. It spot welded, and it handled materials. Now the picture on here is a picture of this first robot. The next type of mechanism is a SCARA. SCARA is a horizontal articulated arm that's shown in the picture with 3 axes, so it can move at 3 points. Its main use is for maximum precision and speed. This is the movement of a SCARA robot and the diagrams. And the last type of mechanism is an articulated robot. An articulated robot has a rotary body that can reach any part of the working envelope. It can be used for material removal, welding, dispensing, and material handling. It is the most common in factories today. And the most complex articulated robots can have up to 10 axes. So it has 10 points. And here is a picture, or the diagrams that go along with an articulated robot. Most of the robots in modern factories and in the video we saw are articulated robots. Okay, so that is where we are going to stop today. Your homework for this week is in Moodle. In the homework, we have an article about how robots are being used to fight Ebola. I would like you to read the article, and then there is a question for you to answer. If you did not share with me today, please make sure the picture of whatever you made ends up on the Moodle website so that I can give you credit for last week's assignment. If you shared with me today, I have given you credit for it. So I do not see Noah's, Seth's, Stephen's, or Isabella's. Oh, no, not Isabella. I'm sorry, Isabella. Or Lindsay's. Everyone else, I saw their robots. So Noah, Seth, Stephen, and Lindsay, I need you to make sure that you get a picture uploaded onto the Moodle site for last week's homework. Does anyone have any questions about your homework for this week? You are certainly more than welcome to build whatever you want with your Connects kit during the week. However, there is no building due for next class, but we will use the kits during next class, so make sure you have them. Otherwise, I hope you guys have a great day. If you want to send me a picture to my email of you and one of your Connects, then you can go ahead and do that. Yes, Dane, go right ahead. Let me turn your camera on. I forgot all about that. Dane would like to share a picture of the largest robot. Yes, you can destroy last week's homework, Stephen, after you take a picture and email it to me. I do not have a picture of yours yet. Dane, go ahead and click the OK underneath your video screen. And let's see the picture. Very nice. Awesome. All right, thank you very much, Dane. We are not building anything, Joseph, for homework this week. You are reading an article, and you are going to answer a question on the article for me. Stephen, why don't you see if you can build something else then out of the kit so that you can do the homework, since I did not get to see it today during class. All right, I hope you guys have a great day, and I will see you all next week.